Good morning. I'm Krista Campbell. Thank you for joining us today for Spatial Business Intelligence, How Customers Have Used Insights for ArcGIS. This is the second webinar in our three-part series focused on Insights for ArcGIS. We will host one more webinar titled Insights for ArcGIS, Digging Deep into Data and Analytics. Today's webinar highlights 4 water organizations that are using Insights for ArcGIS to address their business challenges, each looking for answers to very different questions. Where are customers inefficient with water use? Why are leaks occurring in a specific area? What part of our system is affected by karst topography? How do we increase participation in conservation? Many of you know my colleague Derek Lorbecki. He will lead the webinar today. He is being joined by Robert Pang, Information Technology Manager at East Valley Water District. Robert's going to share how he's been using Insights for ArcGIS to answer several questions at East Valley. Before we get started, I want to encourage you to post your questions. You can post them anytime during the webinar. We're going to have several minutes at the end of the webinar to answer some of them, hopefully all of them. If we don't get to all of them, we will answer them in a Word document and post it on our GeoNet site. The webinar is being recorded, so if you miss any part of it or if you want to share it with your colleagues, we will post this online at our Insights for ArcGIS webpage. And that's all I have for you today. I hope you enjoy hearing from Derek and Robert. Derek, let's get started.
Thanks, Krista. So like Krista said, today we're going to look a lot at what people have been actually using Insights for. I just have a couple of slides and then we're going to get right into it because we have a lot of examples. The 4 organizations that are helping us out today are East Valley Water District from Highlands, California, White House Utility District from White House, Tennessee, Bowling Green Municipal Utility from Bowling Green, Kentucky, and the California Water Service. So the analysis, a lot of the analysis that you're going to see today was performed and came up with at our first Spatial BI forum in White House, Tennessee. This is where we invited about a half dozen or a dozen customers to come out and actually work with Insights and bring some of their data and start actually digging into it. So before we really get into it, I want to first say thank you to the 4 organizations who are helping us out with presenting and with lending us their data today. So East Valley, White House, California Water Service, and Bowling Green Municipal Utilities. I just want to say thank you for helping us out with this and for attending the Spatial BI forum earlier this year. So that being said, let's hop right into it. So I'm going to start off with looking at conservation at East Valley Water District. Some of you may have seen pieces of this before, but East Valley Water District had been affected by the drought like many other water utilities in the West. And they wanted to look at inefficient customer use, specifically tier 3 use, so that higher charged tier of use. So they started off with their meters feature class, which is a meters points for everyone in their organization, and 12 months of customer consumption data. So since one of these is a table and another one of these is a feature class, the first thing they needed to do was actually join these together, in this instance based on this unique account ID. Once these two have been joined together, we now have access to all the tables from both of those features. So they're specifically interested in looking at this inefficient use field, which is a ratio of their actual water consumption to their allocated consumption. So if we take a look at this field and we change the symbology from a counts and amounts to a heat map, what we found is that over the course of a year, essentially there's pockets of inefficient use spread out throughout the entire service area. So to kind of dig deeper into that, we were going to look at if we could find a temporal pattern to that water usage. So by looking at the billing date and the consumption data, what we see is that there are these spikes in water use that start off high during the hotter months and then start to become more spread out and distributed in the cooler months, and then start to pick back up again as the temperature warms up. And specifically, based on this spike in September, when people are generally starting to turn off their sprinklers, we made the assumption that this usage is based on outdoor water use. So people sprinkling their lawns, forgetting to turn their sprinklers off, adjusting to the seasons. So we wanted to dig deeper into that outdoor water consumption to see if we could identify who some of our individual excessive outdoor water consumers were. So inside of insights, we're going to do that using a ratio. So in this instance, we're going to create a ratio using our outdoor water use over our indoor water use. We're going to call that field our usage ratio. So as soon as we run this field, it becomes available in Insights to use. And if we go down to the bottom of our list here, we can see that field, and we can actually create a map from it. Now, when we initially create this map here, you're going to see we have almost 20,000 records in it, which really isn't that beneficial. So we needed to filter this down to a certain subset of individuals to really focus on those who are using the most outdoor water. So in this instance, we're going to look at customers who are using at least 20 times more water outside than they are inside. By applying that filter, we effectively take these 20,000 records and sum it down to the 442 customers who are being the most inefficient with their outdoor water use. We can also look at this data in things like a box plot, and what we can immediately pull out is that there's a subset of customers, of 30 customers who are using between 50 and 110 times more water outside than they are inside. So this gives us a real manageable subset where we can actually go in and look at each of these individual customers and see if there's ways that we could work with them or identify why they're using so much water. So in this instance, we can see this gentleman has a lawn, a lot of trees, and a pool. So it kind of makes sense that he's using a lot of water. But this is an example of answering a water conservation question and very quickly going from a large number of records down to a more manageable subset. Now, Robert's been working with Insights on some other things around AMI systems and water conservation and water loss. So I'm going to hand it off to him now, and he's going to show you some of the things he's been working on. Robert?
Hey, thanks, Derek. So I have 3 use cases. I'm going to focus on AMI today. The first use case is really about problem isolation. The second use case is project planning for AMI implementation. And the last use case, we're going to use AMI leak event data and try to tie that with inefficient use with our billing system to help curb inefficient usage in our service area. Let's start with the first one. So the problem we were encountering was we were receiving complaints of a high number of invalid reads, and we can see that in this card here, where in just the month of October, we're getting over 350,000 invalid reads. So a meter will send out a read on an hourly basis to our meter data management system. So this is significantly high. I can see where it's occurring in the map here, and it's widespread. So based on that and system reports, I'm going to exclude data collectors and communications as a culprit to the problem. So we're going to ask some more questions. Since it's sending reads out on an hourly basis, let's take a look at when the hourly reads actually fail. So from midnight all the way up through the day, there's an interesting pattern that we can see here. Now, this is not the smoking gun, but what we notice is invalid reads taper as we begin to approach the active hours of the day. And as we approach the non-active hours, then they start climbing again. So this is an interesting trend to notice. We'll keep this in our back pocket for later. Okay. Now we're going to take the time element. Instead of by hour, let's plot it by day. We're going to add a new element, and that's by meter make. So a background about our AMI project, we had about 6,800 meters come in the first phase. Of those 6,800, 3,600 were retrofitted, and that would be the Hersey meter make. So clearly we can see we've isolated the problems to Hersey radios. Another way to visualize this is through this bubble chart here, and this sticks out like a sore thumb here. So we know now we've isolated it down to the Hersey meter make, which really is a retrofit. This information was taken to our vendor for further analysis, and what we determined was this was a mechanical issue, not a technical issue. This was a mechanical issue with the meter body. So what happened with the meter themselves, is these Hersey radios still have mechanical wheels in the register. So if the wheel was in between a number for a read, it did not know which read to send out, then that created the invalid read. So this was a mechanical issue that we boiled it down to. This kind of explains this chart here is during the active hours of the day, as consumption is running and the wheels are turning and now the dials are perfectly aligned, we're more likely to get valid reads during the active hours of the day. So through this problem isolation, this information was given back to decision makers and they're able to use that to come up with a plan to rectify what we're going to do with these Hersey meters. In our second use case, we're moving on to phase 2 of our AMI implementations, and we want to determine which routes we should be installing in. So we're route based. So if we install meters, then entire route's going to be covered. So a couple ways we can do this. It's either by meter age. If we want to maximize the meter count, I can see which routes have the most dense meter population here, or if it's just by location. So if I know which routes, let's say our headquarters is here on the east end of the map near the Santa Ana River. If I wanted to target the most far end of our service area, I'm able to select the routes here. So I've got 82, 92, and let's see here, let's call it 81. So I'm going to call it 81, 92. Okay, we're going to go back here. So this is by geographic area farthest away from our headquarters and our meter readers. So I've got meter counts here, but what I can also do is look at an age profile by route. If you notice, the mean age for all routes is about 16 years for the meter. What I can also do is if you have a meter replacement program, and let's say it's 10 years, we can see which routes are still. So I would probably not focus on 101, 84, and 92 if I want to maximize the life of these meters. Going back to our original selection, let me just do that one more time for you guys here. So we've got 94, 82, let's do 81. Our engineering department provided us a spreadsheet with route replacement costs. Now this only covers materials, and that includes the meter itself and all parts associated with it. So from here, I can filter by route code. And I can see here I've selected 92, 94, and 81. We're just going to filter these from our summary cost table. So I'm able to get the projected materials costs for these 3 routes. So if we're working with a budget, we can see how close we are to exceeding that budget for materials. We lack labor data. So if we had reliable labor data to include, we'd be much closer in projecting the actual total costs. In addition to that, we can also decide if we have labor data for in-house labor versus contracted labor. We can make a decision if we're going to do the implementation with in-house staff or through contracted services. Okay. So our next use case, we're still focusing on AMI, and we're taking AMI leak events data, and we want to establish a relationship with inefficient usage data from our billing system. So we have 2 data sets in maps here. The first data set is the AMI leak state. So the size of the bubbles indicate the number of days that there was a leak. The second map is the sum of inefficient usage. And we notice these maps look different. Now this is the interesting part. If I change the visualization here, I want to establish the relationship between leaks and inefficient usage. How strong is that relationship? One way to do this is if I change it to a heat map, we're going to notice something interesting here. Okay. Just by changing the visualization to a heat map, we can see the relationship's pretty strong. These heat maps look nearly identical to each other. So we've established we should really focus on leveraging this leak data from AMI if we want to focus on reducing our inefficient use. From here, we can go even further by analyzing by account class and even looking for outliers. So in this case, we have account numbers plotted out on a scatter chart. And we have one of the most inefficient accounts here, and it has the number of higher days of the leaks. But if we notice here, this account is only 13 days in a leak state, but the cost or the sum of inefficient use is really high. So we can isolate customers to pinpoint and do a little more investigation on. If we want to analyze by account class, a more broader approach in targeting our customers, we can see that the residential account class, they have the most days in a leak state. But if we want to take a different look, and let's look at just inefficient use, this changes. So depending on our strategy, we see if we're just looking at inefficient usage and not leaks, we probably want to focus on multifamily and irrigation account classes. Going back to Derek's point with the ratios for inefficient use, I've also created an inefficient ratio by account class bar chart here, and we can see inefficient ratio, which is the inefficient use over the total allocated budget. The most inefficient account class would be our irrigation commercial customers, followed by commercial account class and multifamily. So this just arms us with conservation and customer service with tools on which customers to identify and help develop their strategy in reducing inefficient usage. So with that, this concludes the analysis of AMI use cases, and I'll turn it back over to Derek.
All right, thank you, Robert. That's really cool stuff. I never actually thought about using insights to look at things like routing for meter replacement until you and I were talking about it late last week. I think that's a really interesting use for it. So I want to thank you for sharing those with all of us. So I'm going to continue on here with a couple of other examples. Moving on to White House Utility District. They're a mid-sized district just north of Tennessee. And they really like to focus on water loss. They had noticed that in a couple of their relatively newer developments, they were seeing what they thought was high water loss. So they wanted to explore the relationship between the age of the development and the amount of number of service requests for leaks at those individual developments. So in here, I've added my parcels, which is coming from the county and contains the age of each development. And I'm going to take my service requests, and I'm actually going to filter those down so I'm only looking at the leaks. So instead of all 300,000 service records, I'm going to look at just my leak request, which is about 17,000 records. Now that I have those filtered down, I can aggregate those onto my parcels, which is going to give me a count of service requests for leaks on each parcel. And that's important because now I can actually look at each of these parcels based on their year built and identify if there's any patterns or trends to the number of leaks we're seeing on these individual parcels. And when I create this chart, we see essentially what we would expect to see, that the older development is, the higher average number of leaks that are being reported on that parcel is. But White House had noticed that one particular area of their district seemed to have a disproportionate amount of leaks on relatively new developments, specifically an area in the southeast of their service district. So we're actually going to filter down this data by that area to see if we can pull out any other information about the amount of leaks that are going on in that location. So we can see here now that I have focused on just this one small area in the southeast of the district. And when we rerun this query, or this chart now in the year built based on our count of service requests for leaks, we see a much different story. And that is that in 2010 or 2007, and to a lesser extent 2010, there was a large number of service requests for leaks coming from relatively new developments. So what were these developments and why this was happening? If I actually go into here and change my symbology to look not at the number of leaks, but at the building code, what we immediately see is that these two locations are both condo developments. In fact, they're two condo developments built by the exact same vendor. And by adding in our material type of our water mains and laterals, what we find is that the laterals installed in these locations were made mainly of copper. It was determined that the copper laterals installed in these locations were defective, and they have since been replaced and have greatly reduced the number of leaks in that area. This got some of the people at White House thinking about other ways they could use insights to take a look at water loss in their area and the potential for water loss. So those of you who have been to the area north of Nashville know that it's a very, very, very hilly area. So there's a great amount of relief in White House Utility District. And because of that, they know the expected minimum and maximum pressure at each service connection in their district. So they wanted to explore whether or not the pressure at that service connection had any effect on the amount of leaks reported at that individual customer. So to do that, we're going to take our parcels again, but this time instead of joining our service request right away, we're actually going to join our service connections to it. And we're not just going to get a count. We're going to look specifically at the expected maximum pressure. So what this aggregation is doing is taking the expected maximum pressure for each service connection and burning it onto the underlying parcel geography. The reason we're doing that is so that we can perform a second aggregation with our service requests to also give us a count of the number of service requests on each one of those parcels. So what we've done here is spatially aggregated two data sets together on a third polygon geography. This allows us to take our maximum expected pressure and also look at the count of service requests based on that expected maximum pressure. When we look at it as a sum, we see what we would expect. There's many more pressures in this middling range, so there's a higher number of service requests. But when we change this to average, something immediately stands out. And that's at about over 200 PSI, the average number of service requests for leaks almost doubles on these locations. So with that information, we can actually take our data and we can filter it down to look at only those connections that have that relatively high level of pressure. So we'll change this to 200. And now that we actually have all of these service connections that high pressure singled out, we can bring in our water mains and laterals, and we can find out which laterals are closest to those high pressure connections by using our find nearest tool in Insights. So we're going to look from our service connections for a water main or lateral. We're going to look for the very first one that we find, and we're going to look within 200 feet of each of these service connections. This is going to return us a feature class that is narrowed down to all of the laterals that are closest to each of these service connections that have a relatively high amount of pressure. We can then actually take this information that we found and we can take a look at the, wrong data set. And we can actually take a look at the material type of each of these laterals to see if there's anything that we can glean from that information. And what we see is that the vast majority of these, are PVC, which stands up relatively well to high amounts of pressure. So this gives White House a greater understanding of where those high pressure connections are and what they can do to help reduce the chances for leaks in those individual areas. So moving on from looking at water loss at a water utility, we're going to go to Bowling Green Municipal Utility. And for those of you who have been to that area of Kentucky, we know that it is full of a lot of karst topography. That's where the Corvette Museum that had the sinkhole underneath it happened a few years ago. And they're particularly concerned about making sure that their sewer mains aren't intersecting, or if they are, they're aware of which ones are intersecting these underground karst structures that they have. So in this instance here, we've brought in both the known underground water flows and the surveyed caves in the district. So I'm just going to change the symbology on these to make them look a little bit nicer. So you'll notice in Insights that you can use the default symbology that comes with the data set you publish, or you can change it to something that meets the needs of what you're looking for in that individual piece of analysis. So now that we have our two areas kind of defined here, that we know we have some of this karst topography, we can bring in our gravity mains. And using Insights, we can actually do a spatial filter on these gravity mains to find those that intersect the individual surveyed caves and also the individual groundwater flows that we're looking at inside of this area. So what we find is that when we look at the material of each of these, that most of the groundwater flows, and in this instance, there's only 29 gravity mains that intersect these caves. Most of these are PVC, and there's just a few that are vitrified clay or reinforced concrete pipe. Of more concern is probably the 283 gravity mains that intercept these known groundwater flows. If we take a look at these materials, what we see is that most of these are vitrified clay pipe or PVC, but there is a number of them that are ductile iron pipe, which we know over the course of many years can become more susceptible to corrosion. So we want to look a little bit deeper at these individual ductile iron pipes to make sure that they're not really old pipes that may need to be realigned or maybe even to be replaced. So we're actually going to take the year installed and the material type, and we're going to create a chord chart with it. So if we take a look at this chord chart and we actually break down by the material type and only look at our ductile iron pipe, what we see is actually pretty good. Most of this ductile iron pipe is less than 35 years old. So there's probably not going to be too many issues with this ductile iron pipe. But looking at it this way kind of got me thinking about how old some of this vitrified clay and PVC pipe may be, because, well, the clay pipe is extremely durable. You know, the older it gets, the more susceptible it is to breakage. So we can actually go inside here and change this visualization up to look at our clay pipe. And what we find is very interesting is that the clay pipe that we're seeing here was mostly installed in the mid-1960s and up to 1975, but some of them as old as the 1930s. So this may be something that we want to focus on to look at inspecting this pipe to make sure that it's sound. That also got me thinking about how old the PVC pipe was installed in these locations. And I found something else very interesting, that it looks like in 1975 is when we stopped installing clay pipe and started installing PVC pipe. So in this example, we were able to take something that is very unique to this area and kind of look at how certain topography and karst features can affect the way that we are managing, installing, and replacing and repairing our infrastructure. So the next workflow we're going to look at is from the California Water Service. And they were very interested in looking at why more customers are participating in their indoor conservation programs as opposed to their outdoor conservation programs. So all of this is going to come from one table, and that's their 2015 Conservation Program Participation Table. This table contains the locations of each person who participates in their conservation programs. And if we take a look at these programs right off the bat, what we immediately see is that there is a lot more people who are using the indoor programs, such as low flow toilets and high efficiency appliances, than are using outdoor programs like controllers, spray nozzles, and turf replacement. If we actually pull this information over into two separate maps, we can look at the distribution of both of these programs. So by filtering, I'm going to look at only the outdoor programs on this map. And let's change the symbology on that to make it look a little bit, make it stand out a little bit more. And on this map, we can look at only the indoor programs. And we'll adjust this symbology as well. So we can see that there's a lot more people using the indoor programs than there are the outdoor programs. And we can even look down and see that the individual programs themselves that are being consumed for each one of these types. So in all of the outdoor programs, there is only 54 people participating in those programs. But in the indoor programs, we have 1,400 people. So looking at that in a little different way, we can see that the vast majority of the people are using these indoor programs, and we are not getting that much usage on our outdoor programs. So we wanted to try to figure out how we could focus in on these outdoor programs to see if we could pull out, through demographics, better ways to focus on these programs to get more people to use them. So by doing that, I'm actually going to re-add this data into my map or to my insights page. And we're going to focus in on the demographics of the people using each one of these programs. So I'm going to symbolize this to show my indoor and my outdoor programs. And the very first thing that I want to do is I want to see what the demographics of people's income and disposable income look like within a certain distance of people participating in these programs. So using the action button, I can get to my enriched data dialog inside of Insights. Inside of this data dialog, I'm going to be able to open up my data browser, which you're probably used to seeing inside of the Living Atlas. So in here, I'm going to look at a couple of different variables. First, my median household income, but I also want to look at places that have a relatively high median disposable income, because they'd be more willing to take advantage of some of these more expensive outdoor programs. I also want to focus on people who spend money on outdoor service already. So inside the Living Atlas, we have access to a lot of variables, including household service variables. In this instance, lawn and garden spend in 2017 on average. I can then actually set a buffer distance on this enrichment to go out 1,500 feet and bring all that data in, so it gives me a better picture of the areas that these people live in and the types of things that we're looking at. So running this actually burns this data into my data set, and I can use it to continue looking at my data based on these variables. So in this instance here, I want to focus in on just my outdoor. I want to focus in on just my outdoor usage. So I'm going to change this to just my outdoor programs. And I want to see that if there's something intrinsically wrong with my outdoor programs, that people in those areas aren't taking advantage of the indoor programs either. So by changing this to a heat map of my lawn and garden spend, I can see that the people in these areas that are using, they're spending a fair amount of money on lawn and gardens, also are in the areas that are spending money on the indoor programs, and there are some of them spending money on the outdoor programs. So maybe I need to look at a different variable. If there's some other way I could tell to see the focus on the areas that are really not taking advantage of these outdoor programs. To do that, I'm going to move away from using a buffer on my points. I'm actually going to move to looking at things by zip code in my area. So in this instance, I'm going to pull in the US zip code boundaries for my area. I'm going to actually enrich those boundaries right from the Living Atlas. So the first thing I'm going to do is aggregate my program participants onto my boundaries. So I'm only including the boundaries that actually have people using my programs. And we can see that we have a lot of people in these areas in the northeast and northwest of my zone, and then not as many people in the rest of these areas taking advantage of the programs. So I'm going to go back into that enriched data dialog, but this time I'm going to focus on housing variables. Specifically, I want to see areas where people own their houses rather than rent them, since we know that people who own their houses are much more willing to invest money into doing programs to reduce the amount of water they're spending on sprinklers and to do things outside of their house since they're relatively large expenses. I'm also going to look at those lawn and garden spends again as well. Since I'm already looking at a polygon, I'm just going to run this, and it's going to give me a join of those zip codes based on those variables that I chose. I can now actually go into this and take a look at my owner-occupied housing and my annual lawn and garden spend. And what we see in this scatter plot is that there is a correlation between the number of people in owner-occupied housing and the amount of money total that area is willing to spend on outdoor lawn and garden services. So I want to focus down even a little bit more and find areas that have a high percentage of owner-occupied housing and see if any of those line up to areas where there are not a lot of people taking advantage of my outdoor programs, because that's going to show me where I should focus the advertising and the work on these outdoor programs on. So inside of Insights, I'm going to create that ratio on my enriched data of my owner-occupied housing units to my renter-occupied housing units. We're actually going to call that ratio our own rent ratio. We can see this data is actually added on the end of the table. And we can immediately use it to look at a couple of different things. So first off, we can take a look at the locations that are going to have these high number of owner to renter occupied housing. So if I look at this a column chart, and I change this from my total to my average, we can see that there's a couple of areas that really stand out here. And I'll adjust my symbology as well to make this easier to see. We can see that the Palos Verdes areas and Ranchos Palos areas in the southern area have a lot of people who have a very high own to rent ratio, along with the Carson area in the northeast of my district. So if I actually start overlaying some of this data together, for example, if we first take a look at my current outdoor program participants, what we can see is that in this Palos Verdes area, we do not have a lot of people participating in these outdoor programs, but it's an area that has by far the highest owner to renter ratio. So this may be an area that we really want to focus on. And if we bring in all of our actual program participants, both outside and inside, what we see is that in general, that Palos Verdes area is not taking advantage of as many of the programs that we would expect them to take based off of their demographics. So this may be a really good area that we can focus on to get more people using these programs, along as you can see with our continuing focus on the Carson area, as there already are a lot of people taking advantage of those programs, but they also have a very high amount of owner-occupied housing. So we've looked at 3 different scenarios here. 4 different scenarios here. East Valley Water District looking at consumption and then looking at ways and insights to view AMI and AMR data. White House Utility District and their focus on continually reducing their water loss to save their ratepayers money and allow for better infrastructure. Bowling Green Municipal Utilities working with the unique topography that they have in their area to determine which locations may need further work and study to make sure that they're avoiding any leaks into these sensitive areas. And the California Water Service kind of taking some of this demographic data and seeing how they can better focus their community outreach efforts to get better buy-in for all of their rebate programs that they have. So before we wrap up here, I just want to remind you that we have a third webinar series coming up called Digging Deep into Data Analytics. I'll have Matt Kennedy from the water team joining me on this webinar, and we are going to be really digging into some complex and deep relationships between data and spatial analytics, and maybe also looking at some ways that you can get your data prepared for use inside of Insights. So with that, I see I ended about 5 minutes before I thought I was going to, so we have some extra time for questions. So if we have any, please feel free.
Thanks, Derek, and thank you, Robert, for participating today. We do have a few questions that are coming in. Let's start with licensing. So we have a few questions about Insights being available as part of your city ArcGIS licensing, or is it something you purchase separately? And if you could speak to individual licenses, or is this a group license? Any information there is helpful.
Yep, so Insights for ArcGIS is licensed on a per user basis. If you have a city ELA that was established before the 1st of this year, you probably have access to a set number of Insights licenses inside of that ELA. Beyond that, if you would like to acquire Insights licenses, right now they are a per seat license cost. So one license equals one person using it.
Thanks, Derek. We also had a couple questions about the data, and Robert could maybe speak to this as well, but where is the data coming from? What type of feeds are being used inside the Insights for ArcGIS?
Sure. So the data sources are mainly coming from GIS. So we have our meters, feature class, routes. The utility billing data is coming straight from the utility billing system. This is where we have our consumption, inefficient use, and also our some other meter data that may not be present in the GIS. Another source from AMI, there's some limitations in connecting directly to the AMI system. So the data source from AMI, we manually pull down reports from the AMI system into spreadsheets, and we would feed that into Insights. So that applies to the leak events use case, and also the phase 2 analysis we did.
And then for the use cases that I showed, those were mainly coming from inside of an ArcGIS Enterprise deployment, with a few of them coming from those XLS sheets. And then all of the data that you saw for zip codes and demographic data was coming from Esri's Living Atlas of the world. So essentially, 4 different data sources you saw: traditional GIS features, Excel databases, data sets, data from the Living Atlas, and then direct links to SQL databases existing at East Valley Water District.
Thanks, Derek and Robert. This question is somewhat related. Our attendees want to know what the underlying technologies are that support Insights. So Derek, if you could talk a little bit about ArcGIS Enterprise and the technology needed to implement Insights.
Yeah, so as of right now, the base underlying technology is a deployment of ArcGIS Enterprise. So that is Portal for ArcGIS, ArcGIS Server, and an ArcGIS Relational Data Store. So those are the 3 things right now that you need to have in order to use Insights. So once you have that installed, Insights is a simple application installation on top of that. And it's actually distributed out across all 3 of those pieces so that they all work together to kind of do the things that we've shown. Now, either late this year in December or early next year, we will be releasing insights for ArcGIS Online. I don't have many details about that, but that will be, you'll be able to actually use insights as a service in ArcGIS Online. So you'll have an option to use it without having that underlying base enterprise deployment. But stay tuned for more information on that, possibly in the third webinar.
Thanks, Derek. In the same line of thought, can you specifically talk about the data store and how that plays a role in insights?
Mm-hmm. So the data store in Insights essentially is a relational data store that is a Postgres data store. And the way that Insights works is that it creates views of the data in that data store for each of those individual workbooks, and then uses those views to create all of the different analyses that we see. So that's why it is so fast compared to doing this in traditional server-based GIS, because we're simply looking at views of data that already exists in the data store and returning the results of those views and those queries back to you in Insights in your browser as you perform them. So all of the heavy analysis tasks on Insights take place inside of that relational data store, which is a Postgres database.
Thanks, Derek. A couple of our questions coming in are surrounding Python or R or any kind of coding. Are customers able to use this to extend or customize Insights?
I do not know the answer to that question, so that's one we'll ask the Insights team about and get back to you in the post question wrap-up.
Okay, well, here's another one I don't know the answer to, but maybe you do. Do you know if Insights is available as part of the home license? And I'm guessing because of the enterprise installment, maybe not, but once it goes to ArcGIS Online, maybe?
I do not know the answer to that question either, but that's something that we can find out and get back to you all on.
Thanks. Yeah, I didn't know that one either. So let's move on to another question about geostatistical tools. Are there many available within Insights that can be used?
So there's a set group of tools underneath that action button that allow you to do some of the core features of ArcGIS, of the ArcGIS stack, such as buffers, ratios, histograms, and things like that. Insights is always adding more capabilities, and as those come online, we'll be publishing out updates to that. So you can take a look at exactly the tools that exist in Insights right now, and you can put suggestions in the ideas or ArcGIS page for other tools that may be valuable to have inside of Insights.
Thanks. Our next question is about dynamic data connections. Can you use these when you're utilizing Insights?
So you can connect directly to data that changes. Inside of Insights, to essentially push those changes through, there is an update button on each data set that you use inside of each workbook. So for example, inside of that White House Utility District water loss sample, as I'm performing that example, I'm looking at the data at that moment in time. But if that data were to update, all I would have to do is go into that model and hit the refresh button, and it would pull the latest data down through it. So it's not a 100% dynamic refresh, but it simply is a click of a tool to update that information. Very, very simple to do.
Here's a question for Robert. How much time did you need to dedicate to getting to learn Insights and start using it so that you began to see valuable results that were helping you to make your decisions?
Yeah, so I think the first step is having data prepared, and if you know what data you have, if it's clean, it's valid, that's your ammo to get going. But as far as time, I felt very comfortable with it. I think Krista mentioned in the very beginning we had the Spatial BI forum, and I think that was just three days of hands-on, and I was pretty comfortable with the interface from that point forward.
Thanks, Robert. Our next question is about sharing data. So if you're using Insights, and we saw a lot of maps and charts both of you were using, how are you sharing these results, Robert? And Derek, if you want to jump in and talk about different ways to share the data, that would be great.
Yeah, so there's essentially a couple different ways you can share information. So any of the derived products you create in Insights, you can share back to your Portal for ArcGIS organization as its own independent data set. So that's one way you can give people access to the raw data you've created in Insights. You can also take any one of those pages and share them out as an Insights page to your organization. So somebody could come into that page and look at all the information. And you can also take those pages and embed them in things like story maps to present those to other people as well. So there's a couple of different ways that you can share that information out. The models that are created behind it as well too, you can also share out. So you can share that actual analysis workflow between people in your organization as well.
Yeah, from East Valley, we share internally. So one of the AMI Phase 2 implementation, we're trying to push GIS enterprise wide. And this really is a self-service business intelligence tool. So if I have an engineer or if I have an ops manager who wants to do his own slicing and dicing and to figure out which routes they'd like to do, I just simply turn this page over to them, and they're able to do it on their own without, with minimal IT support.
Thanks, guys. As a follow-up to that question, so if you're using Insights and you're posting this information, Derek, you said it can be posted to ArcGIS Online. So if your colleagues have an ArcGIS Online login, then they can access whatever you've posted via that channel. But are there different logins for Insights versus ArcGIS Online? And what if they have customers that don't have an identity or a login to one of those systems?
So let me just correct one thing first. Right now, that's you can share it in a portal for ArcGIS, not ArcGIS Online. When the new version for ArcGIS Online comes out later this year, that I'm guessing that will be a possibility. In terms of the licensing, Insights requires a named user inside of ArcGIS and a level 2 named user. And that Insights license is tied to that named user, just like a Pro license is tied to that named user. So it's not a separate login for Insights, but it's tied to an individual who has a level 2 named user inside of ArcGIS Pro or ArcGIS portal for ArcGIS. So like the rest of our tools, ArcGIS Pro Collector requires a named user to access.
Thanks, Derek. That was really helpful. So I think that's about all the questions we have. I would like to remind the attendees that are still on the webinar that we do have a survey that's going to launch as soon as you exit our webinar. It'd be really great if you could just take a few minutes to participate in the survey. This helps us in future webinars, and it'll help us move forward with Insights and ArcGIS Line and all of our planning for next year. And I think we're going to wrap it up. If you did submit a question late, or if we didn't get to yours, I think we got to most of them. We will answer these questions and post them on GeoNet. Hope to see all of you in our third and final webinar. Thank you for joining today.